Hello students, so today we're going to look at simplifying radicals. You're going to want to have your notes, that foldable we made, remember that? Calculator, and then your perfect roots table is going to be your best friend today. So, that foldable, you're going to want to open to this particular tab right here, the simplifying radicals tab. And in here, you're going to want to put 4 marks here. So you're going to want to make 4 spaces on the top and the bottom. So we're going to do 4 separate problems on the top and the bottom, okay? So kind of give yourself, and make sure you have enough room. If you want to make yourself boxes, by all means. Some might be a little bit more extensive than others. So kind of give yourself enough room, just so you're aware of how many you're going to do on the top and the bottom. Have that perfect roots table handy. If you're not, I'll wait. Have that on your hands because you're going to need it today. So on the top here, we're going to look at examples without variables. So on the top of your foldable, you're going to put examples without variables, okay? And then your 4 spots are going to be these next 4 problems. Well, the square root of 40. We've done the square root of 40, breaking it down, right? So you're going to want to find a perfect square that can come out of 40. Well, 4 can go, and then 4 times 10 is 40, right? Oh, that's the biggest. Yeah, that's the biggest, because 10 doesn't have a perfect square. So square root of 4 is 2. So the square root of 40 is the same as 2 square roots of 10, right? That's old news. You've done that before. But what about cube roots? Well, you're not going to take out square roots now. You're not going to take out perfect squares, excuse me. You're going to take out perfect cubes. So on your perfect roots chart, you are going to want to look at this column right here. You're going to want to look at the perfect cubes column. That's going to help you. So let's find a number that's going to come out of 40 in our perfect cube column. 8. 8 can come out of 40, right? So I'm going to get cube root of 8. Cube root of 5, right? Because 5 times 8 is 40. Cube root of 8, look at my perfect roots chart here, 2, right? So this is the same as 2. And then cube root of 5, because 5 cannot break down any further. There is no perfect cube inside of 5. Let's move on to number 3 and number 4 here. Cube root of 72. So same thing, we're going to look at the cube root column. What can go into 72? 8. 8 can, right? So we're going to have cube root of 8 and the cube root of 9. Cube root of 8, 2. And then this will just come down. So it'd be 2 times the cube root of 9. What about 512? What can come out of 512? So it's a 4th root, right? So we're going to look into the 4th power here. 16, I think, can come out, but that's pretty small. That's pretty. I wonder if something else can come out of there. 81. 256. 512 divided by 256. Let me do that quick on my calculator here. That's 2, right? So I can break this into the 4th root of 256 and the 4th root of 2. Not too bad, right? 4th root of 256, that's 4. So I'm going to have 4 roots of 2. Now, that's without variables in there. What about if you get variables? What are you going to do about it? So, these are going to go on the bottom area. So on the bottom area, you're going to want to put simplify with variables. So then you kind of have an idea. This is going to be a little strange. What you're going to want to do is break each piece into its own radical area. So I'm going to break the number first. So 4th root of 625. And then I'm going to break x to the 4th into his own little radical. So what you're going to break everybody basically into his own little area. The 4th root of 625, use your perfect square chart or your perfect roots chart, that is 5, right? The 4th root of 625 is 5. Here's when it gets a little confusing. Well, the 4th root of x to the 4th. Technically, if you think about it, convert this back into using our rational exponents converting, this would be x to the 4th over the 4. Right? And 4 over 4 is 1. Well, think about it. If I take the 4th root of x to the 4th, that's 1. So basically what you're going to do is you're going to think of how many of these I need to have at least 4 each time to pull it out. So I have 4 x's in here, and to get out of jail or the radical, I need to pull out 4 x's. And that's going to just become 1x. So the 4th root of 625x to the 4th is just 5x. Let's try it again. So break it into its 2 pieces. Cube root of 64 and the cube root of y to the 6th. Cube root of 64, that is 4. Now, how many 3's are in 6? Well, 1 3, take out 1 y, and I'll be left with 3 more y's inside, right? Take out another y, take another 3 y's. So technically this is going to break down into y to the 2nd, right? Think about it. If I take out 3 y's, it's going to be left with 1 y, because the cube root of y to the 3rd is just y, and then another cube root of y to the 3rd is just y. So I have y times y, which is y squared. So my answer would be 4y squared, ultimately. Let's try another one. So, break it into its pieces. So, 5th root of 4, 5th root of a to the 10th, and the 5th root of b to the 6th. 5th root of 4, can't do anything about that, so let's just kind of leave that there. A to the 10th. So, I can make this into a to the 5th times a to the 5th, right? So a to the 5th times a to the 5th, because that's a to the 10th, right, if I have my exponents. Well, 5th root of a to the 5th is just a, and the 5th root of a to the 5th is just a. So I'm left with a squared, right? Because 10 divided by 5, you can think of it that way. This one, how can I make a b to the 5th? So I can make this into b to the 5th, right? And then how many b's am I going to have left over? Well, just one more b, right? Because b to the 5th times b to the 1st would be b to the 6th. Well, 5th root of b to the 5th is just a b. But you still have this b to the 1st left behind inside the radical, right? So basically I think of how many 5's can I take out of my exponent. But now what you got to do is put everybody that's on the outside, and everybody on the inside in the inside. So a to the 2nd, b to, and just b are on the outside, right? And then in the inside of my 5th root, I have a 4 left and a b left. So it's going to be 4b left behind. Let's try the next one here. So let's break it. This square root, so I'm going to put a little 2 out there so I don't get confused. Square root of 40. 4 and 10, right? So that's 2 square roots of 10. Break that down. This guy, I can make this into an x squared times an x squared times an x, right? Because 2, 4, 1, 5. Square root of x squared is just x. Square root of x squared is just an x. And I'm left with an x still in the square root, right? Because he can't break out. He doesn't have a 2 there, or a 4, or a 6. So, everybody on the outside, I have a 2 on the outside and 2 x's. So that'd be 2x squared on the outside of my radical. Inside, I have a 10 and an x. And that would be my final answer. I know this is a little confusing. We'll go over a couple of examples in class as well, and you can ask me as many questions as you need. But that's the end of this video. See you later, Sabers.